welcome everybody. I'm Dominic. I'm just going to share my screen and then we can get started diving into the next episode of the Masterclass metric series. Excellent. Right, let's get started. So, hello everyone, and thank you for joining today. My name is Dominic Sellers, and I'm one of the Agile Success Managers within the Customer Success team at Plandec. So, today's session is the second of our two Masterclass webinars. We'll be closing off our discussion on Plandec's four pillars of productivity framework. I'm going to take a deeper dive onto the two remaining pillars, which are the predictability and the quality metrics. And within these, I think these are the most interesting to talk about personally because they're designed to keep you honest with yourself, your organization, and your processes. Once you harness these in the right way and start asking the right questions, they're really powerful indicators which can help you improve your delivery day by day, quarter by quarter. So today, for each metric, I'm going to cover what it measures and why it matters. And then I'm going to jump into Plandec and show you how to set them up effectively to get the most useful insight out of them. By the end of the session, you should have a clearer picture of what the predictability and quality metrics are, how to set up and configure each one to get the right signals for your team, what our top quartile teams do differently, and the patterns that separate them from the rest, and crucially, how to use these metrics to have better conversations at every level of the business, from Scrum Master to CTO. As always, please drop any questions you might have into the Q&A chat, and I'll work through these at the end. But before we dive into the metrics themselves, I want to briefly revisit the productivity framework so we understand where predictability and quality fit. So, Plandec's productivity framework, as you can see in front of you, breaks delivery performance into four pillars. Focus is our team spending the right amount of time on value driving work. Speed measures how quickly an idea moves from concept to production. And then for today, we're looking at predictability. How reliably can teams plan work and then actually execute that plan? Quality is the work being delivered of a suitable quality, i.e., is it reliable and fit for purpose? A few weeks ago, my colleague Matt delivered a great presentation on the other two pillars, focus and speed. If you weren't able to tune in, I highly recommend you go and have a watch either on our website or on YouTube. It's worth keeping in mind today that the four pillars work best as a collective. They all interact with each other and they don't work very well in isolation. So everything we're about to see will be a lot more powerful when you pair it with the context from Matt's session. I like to think of it as if speed and focus are the driving forces of productivity, then predictability and quality are the stabilizing forces. They're what make focus and speed sustainable over time, and it all comes down to a blend of operational processes and culture within teams and organizations. So let's start with predictability. Predictability metrics ask and answer the question, how reliable and consistent are our delivery plans? And that's important because without predictability, planning becomes near impossible. There's no one metric that tells you the full story here. So you're going to hear me say time and time again today, context is everything. An average delivery of, say, 50 tickets over a month doesn't tell you if 50 tickets are blitzed in the first week and then nothing gets done for the next three. Or a team who always hit their sprint targets, they may have more capacity than they realize. So the four metrics we are about to see, they work together to give that complete picture, which helps you understand team performance in a way which will allow you to work the most effectively and unlock that full potential for your team. It sounds like stating the obvious, but a predictable team is easier to plan around, both in the short term and the long term. Teams which have consistently proven themselves to be predictable, they're able to accurately forecast that delivery over longer periods and larger projects. They understand what might pose a risk to their momentum, and they know how to either absorb those unexpected interruptions or bounce back from them quickly. A predictable team is a team that you can rely on time after time to work towards the goals without any concern. And when targets are consistently hit, everyone's happy. That said, none of the metrics here, or any in the framework as a whole, exist to assign blame. The goal is to give visibility on where processes are working and where they're breaking down. If the data says there's something to address, you introduce a change and then you see how the data responds. If it works, great. If not, you iterate and try again. So, the first predictability metric is sprint capacity accuracy, and it's worth being quite precise here about what this is measuring. The capacity accuracy measures whether teams complete the volume of work that they initially planned for. It doesn't measure if the work completed was planned or not, just did the amount of work that we deliver match the amount that we planned at the start. And it's important to remember that because it isolates capacity planning as a standalone variable. It's also our only metric in the framework where both overshooting and undershooting can be problematic. If a team consistently plans for 60 points or 60 story points and delivers 40, that's a capacity estimation problem. If they consistently plan for 40 but deliver 60, that's a capacity estimation problem. The best teams are the ones who understand their capacity and they actively use their historical data to plan for the future. You can see here that in the top 25% of teams on Plan Deck, they stay in that tight window of 88 to 112%, meaning if they plan for 10 tickets, you can reliably predict that they're going to deliver between 9 or 11. Not necessarily all of this work will be the original scope. However, they know that if work gets added or removed mid-sprint, they can accurately predict what the trade-off is going to be. Whereas the bottom 25%, they're consistently averaging between 6 tickets or 14. So why are they planning for 10? Overcommitted sprints cause those natural first order, second order, third order effects of deadline crunches, which can lead to team burnout, leading to corners being cut to meet those over optimistic targets. And that just naturally leads to large amounts of incomplete work or worse, substandard work being shipped. Whereas on the other hand, undercommitted sprints, they slow down the roadmap delivery and they introduce that additional overhead required to add more work mid-sprint. If teams have shown that they're consistently delivering more than planned, then that's capacity left on the table, which could be used to drive that roadmap forwards, clear a bug backlog, or focus on other improvements. In practice, the root cause could be a number of things. Velocity baselines maybe just haven't been recalibrated recently. Maybe there's unaccounted overhead from ceremonies, or maybe there's external pressure to commit to more than the team can realistically handle. But when you do have a reliable handle on your team's capacity, those planning conversations become motivated by data rather than gut feel. These conversations then are much easier to answer and defend. So, how much work needs doing? Okay, well, we can and will deliver that in X amount of time. Some of the team are on holiday, that's fine. We've already taken that into account. Stakeholders might have requested something urgent mid sprint, that's fine, but here's what the trade off will look like. So, the second metric here is sprint target completion. Where capacity accuracy asks about the amount of work, sprint target completion asks, did we deliver the work that we actually committed to? A team might score perfectly on capacity accuracy, but they might miss the deliverables that they committed to. And this is a metric that can be quite visible across the organization. Completing 50% of the planned work is leaving 50% of the work still on the table to be done. And when working towards a large scale epic or a major release, repeating this pattern sprint after sprint will literally double the time it takes to get over the line. But that said, a team operating in the real world will almost always see some slippage, and that's fine. What we're looking for here is pattern over time. Consistently falling far below the target is where a trend can become actionable. And that's when you need to go and investigate. It's probably pointing to something structural, such as estimation habits, story breakdowns, or capacity planning. There's something in that process that's just not quite working for your team. It's also worth keeping in mind how the previous metric, capacity accuracy, interacts with this one. You can draw some very good conclusions based on that. If capacity accuracy is healthy but target completion is low, the problem isn't how much is getting done, but it's what is getting done. You've got to ask why committed work keeps getting displaced. Equally, high target completion and high capacity accuracy. When I say high capacity accuracy, I'm meaning over 100%. That means the teams are completing the planned work and then going on and doing more. So why are they not planning to their capacity? They've shown that they're reliable at delivering what they say they're going to. Maybe you need to account for that from day one. If both capacity accuracy and target completion are low, then maybe the bar is being set too high or they're being absolutely sidetracked with unexpected interruptions. But this leads us into the next metric, which is mid-sprint scope change. Say there's death, taxes, and unplanned work, right? Scope change percent measures how much work is added or removed after the sprint has started. It's the metric that explains why teams miss targets that they thought they were on track to hit. Naturally, scope change is unavoidable as production issues can surface, priorities might shift, and dependencies don't always resolve on schedule. But that's why this metric is important. It separates the execution from the process. A team that misses a sprint target because of high scope change isn't failing in the work that they're doing. There's just external pressure that's coming into play there. High scope change has other impacts. For example, the ceremonies, those sprint planning sessions that effectively become dead time when the planned work gets scrapped and new work gets thrown in halfway through, plus the additional overhead from the scoping needed for that new work. There's the frustration from developers who've had to bin off work that they've been working on for a few days, start again halfway through on something completely different, leaving themselves asking, what was the point in those planning sessions in the first place? This metric changes the nature of the retrospective. Instead of why didn't we hit our targets, the question becomes why was the sprint disrupted and who owns that? And with it, you can have a very different kind of conversation with product and stakeholders. Again, one rooted in data rather than opinion. Because if scope change is consistently high across your teams, you're going to see work get displaced, you're going to see commitment lost, you're going to have focus being broken, and it forces context switching that compounds across the team. And that has downstream consequences on everything from team morale to roadmap confidence. I've said it before, I'll say it again, I'm going to keep saying it throughout today. These metrics should inspire the conversations and the questions. Scope change happens, that's a fact, but it should always be visible, it should always be deliberate, and it should always be understood. The fourth and final predictability metric we've got here is velocity volatility. And this is a new one we've brought in for this year to apply to both Scrum and Kanban teams. So I'm going to spend a little bit more time talking about this one. So velocity volatility measures how much a team's throughput fluctuates from a defined time period to the next. Not what the average is, just how much it swings up and down over a 1, 2, or a 3 week period. The maths behind it is a little bit gnarlier than the others. Given a time frame, we look at your velocities in those 1, 2, 3 week periods. We calculate the standard deviation and the mean average of your velocities, and then we take the ratio of the standard deviation divided by the mean as a percentage. Don't worry about it. I'll show you a worked example in a minute to help you visualize that. But a team averaging 40 points per sprint is meaningless as a planning input if they complete 20 in one fortnight and then 60 in the next. The average tells you nothing about what you can actually rely on them to deliver in any given time frame. So the conversations and the questions around this metric are going to be very, very similar to the sprint capacity accuracy, except that this one is based purely on output and not estimations. So, for example, you're planning a large scale project. Team A has low volatility, so they consistently output between 20 to 24 tickets every week, and they have done for months. Team A tell you that this project is going to take 6 months. Team B, on the other hand, they have a high volatility. 1 week they deliver 10 tickets, a week later they deliver three. A week after that, they're delivering 15. If Team B now tells you they can get it done in 5 months, who are you more likely to trust here? Long-term roadmap vision is crucial to the success of any organization, but the ability to keep that plan moving along smoothly and on time dictates how successful that vision will be. In turn, velocity volatility dictates how accurately you can execute that plan. High volatility makes the roadmap guesswork. Without a clear idea of how much you can reliably deliver, those timelines get over padded with contingency. The thing about it's like trying to drive when it's dark and snowy. It's not safe to go fast because there's no visibility of what's in front of you. So you have no choice but to slow down, go painfully slow, and it takes you far longer than it should to get where you want to be. It's even worse if you go the other way, go too fast, set a timeline that's too optimistic, thinking, hey, that team did 30 tickets in the last 2 weeks. Let's use that as our baseline for the next 6 months. Those over-optimistic timelines cause headaches all the way from the engineers who are struggling to sustainably meet those checkpoints over a prolonged period to the execs who are scratching their head wondering why the roadmap's behind. Whereas low volatility helps you sleep at night, safe in the knowledge that your plans are rock solid, backed by data evidence, and are likely to be hit with your targets. Or at the very least, if there are delivery concerns or interruptions, you're going to get the warning signs well in advance before it's too late to recover. That's the importance of this continuous monitoring of team performance. It's not a case of look at it once a month, not look at it at the end of the quarter. It's that consistent monitoring. And we'll get onto that a little bit later as well. But confidence is what allows you to drive faster, safer, both in your metaphorical car and within your business roadmap. But volatility goes deeper than just the numbers. So again, I'm going to say use it to ask questions. Here you might want to ask questions like, why is our velocity fluctuating so often? Is the work well defined? Are the teams aligned on effort estimation? And you might find something else like, Unplanned interruptions are constantly coming in, consuming capacity and derailing flow, or maybe the team handles disruptions really well and it can take them in stride. Maybe the output fluctuates surrounding events like major releases or team rotations, which you can't avoid, but you should account for. Or there might be external dependencies for a team, such as other teams or third parties, which are introducing unpredictable roadblocks and hamstringing their productivity. These are the questions and the answers that the data don't tell you, but they can tell you that there is something there that you will want to know about. The aim isn't a 0% volatility. It's to use this metric to understand the teams, find the pain points, resolve them, and just try and make everyone's life as easy and happy as possible. So now that's the final predictability metric. I'm going to jump into Plan Deck now and we'll show you how to get these set up effectively. And then after that, we can move on to the benchmarks and the impact of AI on those benchmarks. So I'll jump into Plan Deck here. And if you want to set up a predictability dashboard, we have these templates set up for you already. You just go to Manage Dashboards, add Plan Deck templates, and then down here we have a predictability one. And this will pre-add all of the metrics we've just talked about. So when you do that, you'll get something like this popping up. And this is our sprint capacity accuracy and also our scope change metrics bundled into one. So you open it up with Explore View, and I've already applied a few filters for you here, but the standard filters that we like to apply, because we're looking at sprints, we're going to exclude either the really high level or the really granular tasks, but also subtasks, epics, initiatives, things that don't quite accurately monitor a sprint value the same way as a story or a task would or a bug. And you can see now, oh sorry, we've also got other resolutions that we want to get rid of. So anything that's like declined, descope, duplicate, things that you don't want affecting your numbers, we can exclude those as well. And then you get something like this, where you have two lines. And you've got the blue line and the green line. Blue line tells you your commitment, and the green line is telling you your velocity. And it's really important that you remember here in the calculation tab, there's a few different settings you can use. You can flick between tickets and story points. So for now, I'm going to stick with tickets, but if story points is more aligned to your team, by all means use that. And for both velocity and commitment, you have the choice of choosing whether you're looking at the total amount, i.e., everything that was done throughout the sprint, or just the committed. So everything that you had on day one of that sprint. And because we're looking at capacity accuracy, we're looking at the volume prediction accuracy. So we're looking at our velocity is going to be how much work we completed in total. Our commitment is going to be how much did we commit at the start. So how much did we think we were going to be able to do? And when you look at this example here, you can see that this team is consistently outputting more tickets than they originally planned for. It has got better. You can see that this is quite a big gap to begin with. It's at 265% completion. And this team has taken this data into account and is now actively working to get this closer and closer to their predictions. So if you go on to the next tab, something went wrong is not what you want to see right now. Let's try that again. Fantastic. Okay. We'll have to skip that tab. We'll try again a little bit later. Apologies for that. You can also see the scope change. So you might be thinking, well, where did these other tickets come from? The 53 tickets when they only committed 20. Well, that's where the scope change comes in. Naturally, that means there's been quite a high level of scope change, so more tickets being added after the sprint has started. See that they've actually added an extra 38 tickets onto this sprint, which as a percentage of your initial scope is 190%, which begs the question, why are they not planning for that to begin with? I'll give this one more shot. Hey, we're in. Cool. Now you have a more complete view, excuse me, of this is now the total commitment and the total completion, but it's broken down into the committed that was planned from day one, committed that was carried over from a previous sprint, and committed that was added after the sprint has started. And you same for completed. You can see that there's a really large chunk of work that's been completed after, well, it was added to the sprint later and it was completed. So that's a good trend. And you can see that this team's done a really good job of trying to bring their capacity accuracy in line based off their historical data. So you can see here that there's 31.2 tickets. That is a historical average for what they've done. And they can use that going forward as a potential target. Sprint completion, 184%, 185. That's their capacity accuracy averaging these sprints. And the ticket change is their average scope change throughout these sprints. You can also change it. So instead of just looking at all of the sprints, you can scroll down and just make it look at the last three or the last five. So you've got better vision of those improvements as you're introducing those changes. But we want to see their sprint target completion. So the next metric that you'll see, sprint target completion, a little bit simpler to understand and read this graph is just of the tickets that they committed in that sprint, how much did they complete? So you can see that this team's exceptionally good at hitting their targets. This one, they hit all of their targets and then went on to do more work. So they've proven that they're very good at hitting their target. So there could be capacity, well, there definitely is capacity left on the table here for these teams. And also sprint work added completion, not one of our benchmark metrics, but it's effectively the same thing, but for uh, not the work that you committed at the start, but of the work you added later, how much of that completed. So the new velocity volatility metric that you can see here, what this does, we've applied the same filters. So just getting rid of the large and the small tasks, getting rid of those negative resolutions. And I've just filtered it to look at the snowstorm board again. On the calculation tab, we're looking at tickets and we're going to look at a bi-weekly granularity. So in 2 week chunks, what is their velocity for that 2 week chunk compared to the next 2 week chunk, compared to the next 2 week chunk? And you can see that this is quite volatile. Middle of Feb, middle to the end of February, 23 tickets. Beginning of April, 8 tickets. So there's quite a high level of volatility there. And you want to be asking the question, okay, well, what happened between that time frame to change so dramatically the output? So you can see that the average velocity here is 23 tickets, standard deviation and volatility. If we click into here, you can actually see the calculation that we do to get to that number. And I'll just show you that there for a second. So with predictability, it's also worth knowing that the data is just one half of it. You want to get an idea of what's happening on the ground, what is the team sentiment. You also have this DevX module up in Plan Deck, and you can go and have a look at some templates of questions you might want to be asking and things you can also send out to your team to get their opinions on. So productivity, health, for an example, ask the sentiment on questions like, can we reliably predict when work will be completed? And are we getting impacted by unexpected or unplanned demands? Final thing for the predictability is also velocity volatility, but however, this is at a team level. So if you have lots of boards in your workspace, you can actually break it down by board and it will show you the average for all the different boards that you have within that workspace. So we can see that Snowstorm, which we just looked at, was about 66%, but then this is also for everyone else as well. And then it shows you the average. So this is more useful for a portfolio view. So that will be uh, the predictability metrics. And I'll go back to the slide. Here, you can see the gap between the top performing teams of predictability for sprint target completion. You can see that there's 20 percentage points difference between the bottom quartile and the top quartile. This is a subset of teams on Plan Deck for those who use AI. But I don't like to think of this as the 20% percentage points. I like to think of this if my team is doing 49% of their sprint target completion, and then through carefully targeted process changes, have improved out of the bottom quartile and now reached the top quartile. That self comparison, that self improvement is actually 41% more productive. So 41% higher than 49 gets you into the 69% productivity. So making that change has made a massive difference on that team. And those are just based off the boundaries. In reality, you might be even higher. And here's another breakdown for teams on plan deck that do use AI tools versus those who don't, and what the different benchmark quartiles are. Naturally, most teams enter this conversation in the second or third quartile, and it means there's a very clear and reachable improvement journey ahead. Those who are in the top quartile naturally want to fight tooth and nail to stay there. The top quartile teams don't ever have zero scope change or perfect capacity accuracy, but they have consistency and they've got a small variance in their performance. Any disturbance to their data is deliberate and the impact is well understood. And because their process is stable, their delivery data is trustworthy to plan against. Because predictability leads to trust within the team, within the leaders, and within the stakeholders looking in. So this is all the data that comes from our own platform, aggregated against thousands of engineering teams on Plandeck. So you can see that there's a bit of an uplift in the sprint capacity accuracy performance for the teams using AI tools. And that's because capacity accuracy is a discipline which takes time to build. Bottom quartile teams might still be establishing those habits, and AI isn't going to be a golden bullet that saves them. But the top quartile teams who understand their agent's capability with accurate prompting, smooth workflows, efficient reviews, they can reap the benefits of that. Using other plan deck tools as well, such as the Gen AI module, you can see how your AI acceptance rate, your daily adoption is being used to help you better understand how it's working within your business. Sending off an agent and hoping for the best won't improve your accuracy. As I mentioned earlier, predictability is a blend of operational processes as well as cultural practices. So it can be tricky with AI because it comes down to a range of these different constraints, whether it be systemic, organizational, cultural. We have several webinars on our website and YouTube on this topic. I would also highly recommend these. Our COO takes a deep dive into the constraints into the agentic SDLC. So that's predictability. Four metrics that tell you if your teams are planning well, executing their commitments, and operating with the type of consistency that your business can plan around. So now we're going to move on to quality. Quality in the context of software delivery is not about whether the product works. It's about the rate at which defects are being introduced relative to new value being created, and also whether the team is dealing with those defects before they compound. And the reason that this matters is different for different levels. So at a team level, the bugs you don't fix today don't disappear. At some point, you're going to have to turn around, go back and fix them instead of working on the fun stuff. At the leadership level, quality metrics are that signal that tell you about the sustainability of your delivery pace. Teams can ship fast for a while by cutting corners on quality, but the correction always has to come eventually, and it's normally more expensive than the time you saved to begin with. So there's three metrics in the quality picture. The first one is bug resolution time, and that's how long it takes from a bug being raised to it being resolved. Bugs get harder to fix the longer they sit in the code base, and it's not a linear relationship either. An engineer who knows the bug today or who raises the bug today, they have the context to fix it today. They know the code, they know the intent, and they know the edge cases. Come back to that bug in 2 weeks, and you're trying to navigate the new code that's been built on top of it. A month, 2 months down the line, you might be having to start from scratch with exponentially more regression risk there. While all that might be true, think about some of the different scenarios and interpretations here. What might a sudden spike in bug resolution time represent? It might not be a red flag if you know that your team has made a deliberate decision to go back and tackle those old tricky bugs to clear down that backlog. That will naturally spike the resolution time, but it's a positive signal. Conversely, if a team is cherry picking the easy bugs, just clearing out the quick ones as they come in, and ignoring the old ones, then it's the opposite story. So context is everything, and it's important to look at the wider picture and ask the right questions like, are we prioritizing the correct bugs at the correct time? And where in the fix process are the bugs getting stuck? So we'll see some other interpretations in the demo shortly, but as a little hint, things like priority, environment, epic groupings are all other treasure troves of information that you can dive into with your quality metrics if your Jira or Azure DevOps is kept neat and tidy. So the second quality metric, stories delivered to bugs raised ratio, and it measures for every user story delivered, how many bugs are being introduced. Not necessarily related to the work delivered, it's just a simple work out versus bugs in. A healthy ratio tells you that a team is shipping new value, and they're not accumulating defects at the same time, and or at least not accumulating defects at a rate that's eventually going to consume their capacity. A deteriorating ratio is the early warning sign of an unsustainable practice. But it's an iterative loop, right? So when the signals show that the pace is outrunning quality, it's an opportunity to gently apply the brakes, find the root cause, and address them before picking up the pace a bit further. So is your test coverage sufficient? Can it be automated further? Are there knowledge gaps in the team? Are the stories and pull requests too large to effectively review? Are all examples of causes that you might have of a deteriorating quality. It's also a cross-pillar story, this one. It works closely with focus and speed because this metric is a two-horse race. Who's winning out of stories and bugs? You could go fast as possible to ship as many new features as you can, but is the quality taking a backseat, a sacrificial lamb in the name of maximizing throughput? You might outrun the bugs for a week or a month, but the backlog's not going away, so you will inevitably need to divert capacity away from delivering value to go back and fix those bugs. And nobody's happy when all of this quarter's work is put on pause, so you can go back and redo all of last quarter's work. But really pay attention to the gap here between the top and the bottom quartiles. Those top 25% teams are seeing over 3 times the value delivered for each bug raised compared to the bottom, which is just a staggering amount. That said, it's possible to gain this, right? You could make your stories smaller to try and bump up that numerator. And maybe you should. Smaller stories mean smaller, more incremental changes. And you can probably see where I'm going here, but smaller stories means easier code reviews, easier, quicker testing, which in turn will reduce your escaped defect rate. So it's twofold. Your stories go up and your bugs come down in just one simple sort of process change. And this will also feed back into your speed metrics if you apply the same logic to your pull requests. It's one of the ones that's most obviously associated with the impact of AI tools in the SDLC. Agentic AI is accelerating story output at a crazy fast rate. With higher throughput, your stakeholders are initially happy, but any constraints in your AI adoption will make themselves known here. For example, if your requirements aren't well defined or the testing is lacking coverage, it could be costly. So instead a structured implementation, whether it be an incremental rollout or supported by clear usage guidelines, will allow you to keep on top of those warning signs if and when they appear. And once the adoption's rock solid, you're going to see this skyrocket. So to summarize, the goal isn't to pump out more stories quickly, nor is it to spend months on every item ensuring that no bugs ever exist. It's finding that sustainable balance which allows your roadmap to power on without unmanageable damage. And the third and final quality metric is the bugs resolved to bugs raised ratio. And this one tells you about the rate of defect elimination. Specifically, the questions, is the team keeping up with the bugs being raised or is the backlog growing? So a ratio above 1 means that more bugs are being resolved than raised, which is good. A ratio below 1 means the opposite. So a sustained ratio below 1 is a clear indicator of compounding quality debt, and it's a very predictable precursor to a quality crisis that's going to force a team to stop their feature delivery entirely to go and dedicate time to squashing these bugs. It's also one that we see can be quite a shock to team leads, as it's not uncommon for this metric to tell a slightly different story to what they think is happening on the ground. Sometimes after a dedicated effort that's been made to go back and reduce that bug backlog, using this metric, they can see that it might have actually fallen slightly short of a recent surge of new bugs that was raised in the meantime. So what do? You ask the questions, you investigate where the leak is in your process that's allowing these bugs to grow. So all the questions that we've looked at in the previous metrics, and also things like, do we have sufficient capacity to keep on top of this? Is our future roadmap at risk due to this looming quality debt? So reading that alongside the stories to bugs ratio and the bug resolution time, this ratio completes that quality picture. And together, the three metrics tell you how fast bugs are being introduced, how long they're sitting in the code base before you're fixing them, and whether the overall backlog is growing or shrinking, which gives you a really good, complete, actionable view of quality health. And that works equally well for a team lead or a scrum master looking at team level patterns, and also for a delivery manager looking at portfolio level risk. So jumping back into plan deck, we can do the same things we did before. We have these plan deck templates, the quality, and then you'll see a list on here. Bug resolution times, just telling you how quickly the bugs, the bugs resolved in this time frame. How long were they open for? This doesn't tell you too much by itself, but you have a load of different filters, breakdowns, and other views that you can use to get some really good insights out of here. So, for example, fixed version, if our ticket hygiene is good, we can see more categories and breakdowns of where the problematic fixed versions might be. We can break it down by priority to say, are we picking up the right bugs at the right time? I do apologize if I'm getting some background noise. The heavens have just opened and my window's getting pelleted with hail right now. Hopefully you can all still hear me okay. So here we can see that the P1 tickets have been closed really quickly within a day. That's what we want to see. Uh, might be asking a question why there's two different high priorities, so maybe there's a hygiene issue there. But generally, this is like what we want to see. The lower priority tickets can sit for a little bit longer, but the high priority tickets are being picked up really quickly. Similarly, by status, you can see where's taking the longest. So it's biggest bottleneck here. Bugs are all waiting refinement for longer than any other status in there. We can also filter the outliers as well. So sometimes there are a few stragglers who do really skew those numbers, so you can exclude those with the outliers there. The next one, stories delivered to bugs raised. You can actually add this directly as a metric now without having to go through the configuration yourself. So by searching stories delivered to bugs raised, it'll give you this view here, and it's two metrics overlaid with each other plus a ratio overlay. The first one is how many stories have been delivered, and you can change the filters, whatever fits your case. And the second one is how many bugs were created in the same time frame. And you can turn the metric on or off, depending on whether you want it there or not. And here, you've got to take a little bit more time to take a look into it. But you can see that the orange line is the stories delivered, which is fluctuating a fair bit. Maybe it'll be better if we go into a monthly view. So let's have a look at January to the end of April. Bit smoother here, and you can see that the stories delivered is starting to drop, but the bugs raised is also starting to drop. So whereas the ratio was below one, through some targeted improvements, that ratio is creeping up and up, and we're now delivering more value for every bug that's being raised. If you also have other filters here as well for your bugs raised, you can look at things like filter out the environment if you do label that. So you can filter out your production bugs from your bugs found in testing or internal environments. And then you can also do the same for bugs resolved to bugs raised. So again, that's in our catalog of metrics, bugs resolved to bugs raised right here. And it just pre-configures it for you. Very similar to the last one, except instead of stories delivered, we're looking at bugs resolved. And here we can see similar story. Bugs raised is starting to go down. Bugs resolved is also going down, but we've managed to get that ratio so that we're resolving more than we're raising, which if we can sustain that, means that that backlog will start to shrink in time. So those are the kind of patterns that you're going to be looking for. We also have a quick shout out to the product team who done a really, really good job on putting out these SoniCube metrics. So SoniCube is a really useful tool for monitoring your code quality before it becomes an issue. So you can see here there's a load of new metrics for quality scans, code complexity and coverage. So have a look at those on the catalog if you want to use your SoniCube to help out with that. It's more for your proactive bug containment rather than reactive. So just jump back to the slideshow. We'll get this wrapped up. Similar slide again. We see here teams using AI tools versus not. I want to quickly point out the teams who are using AI tools, the bottom quartile are at 1.6 stories delivered for every bug raised. That places them in the upper mid quartile for the overall platform data. And not only that, regardless of using AI or not, the teams who are in the top quartile are, yeah, it's over 3 times here. And if you're using AI, you're actually doubling your value still. There's a lot of reasons for why AI is doing this. The AI tooling requires better story definition up front, so forces the engineers to be airtight in their requirements. Your AI doesn't fatigue from relentless code review, and it can also generate new, update existing test cases much quicker. And both of those will free up your engineer's capacity to focus on delivering those new value. And that's just to name a few. So, to summarize and wrap it all up, bring the full picture together. Predictability and quality, what do the top quartile teams actually do differently? Well, they're honest with themselves. They plan with realistic capacity, not aspirational capacity, and they recalibrate when the data tells them to. They protect their sprint commitments from disruption, but when disruption is unavoidable, they assess it and they track it. They acknowledge bugs exist and they use these as a planning input. Rather than kicking the can down the road, they keep their resolution time short and their resolved ratio stays above one, as does their stories delivered to bugs raised ratio. Most importantly, they review their data regularly. As I said before, not monthly, not quarterly, continuously. If you've watched our previous webinar, to quote a wise success manager named Matt, teams who engage with their delivery data more frequently are widening the gap, not just maintaining it. The distance between the top and bottom performers is growing, and regular data review is in itself a differentiating behavior. So the bottom line is none of these metrics work in isolation, but together they give you that complete and honest picture of how your performance truly is. The benchmarks tell you where you stand, and the metrics we've walked through today will give you the tools to understand why and to have the right conversations at every level of the business about what to do about it. So thank you very much for joining us today. That's all from me. And you see that we've got in the Q&A, predictability metrics are based on agile sprint estimates. Agentic AI teams look to be moving away from this. What's the advice on handling this? That's a really interesting point. The You are correct. The predictability metrics were originally based on those agile sprints. That's why we're introducing things such as velocity volatility, so we can try and get a better handle on this. Um, I can reach out to you individually to see how we can evolve the framework and other metrics that might be useful for this case. The framework metrics are just some that we use for benchmarks. We do have a lot of other predictability metrics in Plandeck. We have a lot more code repository data. We have things like build failure rate, um, which can all, like I say, they all interact with each other, the different pillars. So this might be a case where across pillar metric portfolio might be the best way for getting the view that you need there. But if you've got any more questions about that, you can actually just reach out to us on Plandeck. There's a little chat icon, and if there's something particular that you want to get set up for your dashboard, we can definitely look at the cases for that and make sure that you're getting what you need out of the platform. Excellent. I think that will be everything for now then. That's everything for the Q&A. Any other questions, like I say, please reach out to us either on the support chat on the Plandeck platform or just email us directly. I really hope you've enjoyed today's session and I hope you have a great rest of your day. Take care.